All right, very good evening to all my dear lovely students. How are you? Good evening, namaste. निरांत नमस्ते कैसे हो आप सब कैसे हो? Hello Naru, I am also good evening Alia. For so many good evenings, now my good evening is very good. Ashika, hello Ashika. Srinivas Reddy, good evening. Arifa, good evening. Bharti, Sonali Yadav, Reshma, Arifa, Bestie, Mr. Panda. You know, my nickname was also Panda when I was in 5th class or 4th class. My friends used to call me that. Good evening. Where am I from? I am from Haryana, beta. Born and brought up in Haryana. Lasya, good evening. Nandu, good evening. Hello. Sufyan, hello, good evening. My Telugu is good. I know only 5 words in Telugu. Okkati rundu, mooru, nalugu, aidu, aru, and some more. Good evening. Tummadi, Animadi. Good evening. So we have got 9 likes right now. Okay, 125 people are online. Quickly make it 80 to 90 likes. Hello, good evening. Yes. Then we'll start our class today. Today we'll be studying about how to draw the structure by a next method. Okay, by a better method. Jaki Reddy Venkateshwar, very good evening, beta. Tenth like Bharat Reddy. Quickly make it 90 to 100 likes. We'll start the class. Okay. Vasu, good evening. Good evening, Janu, Gantala. I had my lunch. Yes, thank you. Okay, guys. So we'll be starting our class. Okay. Till now, what we have done from this chapter is just Lewis dot structures I have told you how to make, and wherever you will get a wrong Lewis dot structure, just make a double bond with oxygen whenever the central atom belongs to period 3. Okay. So this is the one, story of oxygen, story of nitrogen, CO2, CH4, ammonia. Till now we exactly don't know why I have made ammonia like this. Okay, so we don't know anything about geometry, what is pyramidal shape, what is going to be tetrahedral, linear, how exactly the atoms are to be arranged. We have no idea from Lewis structure. So that I will tell you today. Sometimes structure will be bent shape like this, bent or V shape like this. Sometimes structure will be, equilateral triangle like this. Sometimes structure will be equilateral triangle like this. So we don't know why these type of geometries and structures are coming. That we will be dealing with today. Linear, tetrahedral, and so on. So let us start today with drawbacks of Lewis dot structure and go to a better theory, hybridization and VBT. You can write quickly drawbacks of Lewis theory. Drawbacks of Lewis theory. Sir, we can stop the chat. Drawbacks of Lewis theory. So there are many compounds which do not follow the octet rule. When any compound does not follow the octet rule, it can either have like less than 8 electrons in the valence shell, or it may have more than 8 electrons in the valence shell. Less than 8 electrons in the valence shell, we call them as hypovalent compounds. So number 1 you can write hypovalent species. So there are many molecules which are stable but contain less than 8 electron in their valence shell. Okay, species, by species we mean to say any molecule. Any molecule in which the atom may be stable but has less than 8 electrons in its valence shell. Who are these compounds? How to remember the example? Okay, in NEET 23, sorry. In NEET 2023, direct question came from here. They gave you a bunch of like 5-6 compounds and they asked how many of them do not follow the octet rule. So in that, all the examples were there. How to remember the examples, everybody? Please remember very easily, I'll tell you. Hypovalent species are always going to be beryllium dihalides, means beryllium making 2 bonds, BeCl2, BeF2, BeBr2, like that. And boron or aluminium making 3 bonds, BF3, BCl3, BH3, like that. So we'll write the examples, okay? Examples you must learn. Example, beryllium chloride, BeCl2. This is how BeCl2, BeF2, BeH2, okay? These 3 examples you learn first. Here, beryllium has only 2 bonds around it, one this side, one this side. So beryllium actually has here 2 electrons in the valence shell, like this. This is BeCl2. This is BeCl2. So when you look at BeCl2, around beryllium only 4 electrons are there. So beryllium has only 4 electrons in valence shell. But it is still stable. BeCl2 exists in nature, very stable. So to become stable, octet is not the requirement. There might be other requirements, okay? Same, all of them look the same. Then boron with 3 bonds, BH3, BF3, BCl3. Okay. Then aluminium with 3 bonds, AlCl3, AlBr3, etc. These are the examples of hypovalent species. Hypovalent. Boron with 3 bonds. So BF3 I am making. This is BF3. Boron has 3 bonds around it, like this in BF3. You cannot draw these structures by TVSU, mind it. You cannot draw these structures by TVSU because TVSU will work only where the 8 electrons will be there. Here the 8 electrons are not there. So TVSU is useless here, okay? Remember it, don't even try to check. From now on, you will never draw any structure with TVSU. Remember it, don't use TVSU. Finish, over. Whenever the question was draw the Lewis dot structure of any compound, they will give you that compound only which will follow the Lewis rule. Then you use TVSU. Now in the drawbacks, whatever examples I am giving, don't try to use TVSU. You will get a wrong answer. Okay. So this is the one. So this is BF3. This is BF3. And around boron there are only 6 electrons here. 1, 2, 3, 4, 5, 6. So boron has 6 electron in valence shell. Okay. So hypovalent species are stable, but still they do not follow the octet rule. Second drawback comes the opposite. Those who have more than 8 electrons in their valence shell. I told you in the last class, no, sulfur, phosphorus, these people belong to period 3. They don't have a compulsion to keep 8 or less electrons. They can keep more than 8 also. So they will not be following the octet rule. Hypervalent species. Hypervalent species. Hypovalent in other terms is also called as incomplete octet. Hypo means incomplete, less. Incomplete octet. And hypervalent are also known as expanded octet, means they expand their capacity to keep more than 8 electrons. So these have more than 8 electrons in valence shell. More than 8 electrons in valence shell, but still they are stable only. We call them as expanded octet. Expanded octet. Correct? Let us see the examples, everybody. How to remember the examples? Here examples will always be having, central atom who belongs to period 3. Because I told you period 2 people, boron, carbon, beryllium, nitrogen, oxygen, fluorine, they can never violate, they can never go above the octet. They can stay below the octet, not a problem. These are the examples of below the octet. But the people of period 3 can go above the octet. Examples, most common examples are PCl5, everybody. You think if phosphorus wants to keep 3 chlorine around it, 5 bonds it has to make at least. 5 bonds means 10 electrons around the phosphorus. Okay, 5 bonds means 10 electrons around the phosphorus, like SF6, like XeF6, like IF7, like sulfate we saw in the last class, sulfate, SO3 we saw. Okay, SO3 I told you, SO4 to negative you have drawn, phosphate you have drawn, PO4 3 minus, ClO4 minus you have drawn. In all these cases, what was happening was, wherever oxygen was getting a coordinate bond, we were changing it to a double bond, and then they were, not following the octet rule anymore. All their structures we will be drawing by a better method, hybridization method, which will be much easier than TVSU, much easy, very, very simple. If you know basic mathematics, division, if you know division, how to divide by 8 and how to divide by 2, if you just know basic table of 8, drawing the structure will be very, very easy for you. All these structures will be drawing in the today's class. Okay, so these are the first 2 drawbacks. Third drawback you can write. There are many stable compounds in which they have, odd number of electrons in the valence shell. We call them as odd electron species. Odd electron species. Obviously, when valence electrons are odd, in that case octet rule cannot be followed because 8 is the even number. So beta, odd electron species, we study them separately. Okay, we generally don't keep them in hypo or hyper, although you can keep them. If electrons are 7, you can keep it in hypo, less than 8. If electrons are 11, you can keep it in hyper, more than 8. But we study them separately because their properties are much different from the even electron species. Okay, so we'll write the example of odd electron species like, remember their examples, NO2 is very important example, NO is very important example, ClO2 is very important example. Okay, these are all important examples of odd electron species. Very, very important beta. Here nitrogen will have an odd electron. Here nitrogen will have an odd electron. Here chlorine will have an odd electron. Their structures cannot be made by any trick. You have to learn the structures. Okay, you have to learn the structures. So we will learn their structures. So we have to draw them by our imagination. Okay, this is one thing that you have to do. Draw with the imagination only. There is no TVSU, there is no other trick which will work for them. 3 odd electron species I am telling you, kindly learn their structure. Okay, let's learn them. NO2 beta. See how Lewis would have thought NO2 ka structure. Nitrogen, oxygen, oxygen. Oxygen brings 6 electrons. Nitrogen valence electrons are 5. I am drawing 5 like this. 1, 2, 3, 4, 5. These are the valence electrons of nitrogen. These are the valence electrons of nitrogen. I'm just drawing a little bit far away from nitrogen. So yellow ones are the valence electrons of nitrogen. Oxygen has 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Carefully see everybody. Oxygen says, nitrogen, I have 6. To complete my octet, I want to share 2 with you. So you share 2 electrons with me so that I become 8. Nitrogen says, okay, I'll share these 2 with you. Nitrogen says, okay, I will share these 2 with you. So as soon as nitrogen shares these 2 electrons, oxygen is to happy now. Oxygen says, I am very happy. Oxygen says, I am very, very happy. My octet is to complete. Okay. Other oxygen also comes and says, nitrogen, I want to share 2 electrons with you. Nitrogen says, if I share 2 electrons with you, there is a huge problem. There is a huge problem. If I share 2 electrons with you, I am going to have 9 electrons. Can I keep 9? I am going to have 9 electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9. Not possible. Go away. I can't share 2 with you. That's what nitrogen says. I can't share 2 with you. So in return, oxygen will say, okay, then what should I do? I will not share my electrons because otherwise you cannot expand your octet. What you do is nitrogen, you share 2 electrons with me. Let's make a bond. Let's make a bond where all the electrons you only donate. All the electrons you only contribute. I will not contribute anything. That bond is called as dative bond. That bond is called as beta dative bond. For example, if 2 people want to start a business, okay, this is friend A, this is friend B. There are 2 ways they can start a business. Let's say to start a business, you need 1 crore rupees. You need 1 crore rupees. First method is B says, I will bring 50 lakhs. A says, I will bring 50 lakhs. Let us equally put money. 50 lakhs you put, 50 lakhs I put. Total become 1 crore and let us start the business. This is called as equal sharing. This is called as equal sharing. Equal sharing leads to a normal covalent bond. Equal sharing leads to a normal covalent bond, like these ones. All the bonds which are shown by a single line, they are called as normal covalent bond. Where A has bought half the electrons, means 1 electron, B has bought half the electrons. So B brought 1 electron, A brought 1 electron, they put their money together. This is normal bond. Other method is also there to make a bond, where B says, see, I am very poor. I am very poor, but I am your friend only, na. So I want, to have a business with you. I will take care of all the things. Just like you, I will also sit at the shop. I will also take care of the finances. But initially, I don't have any money to, invest. Please bring all the money yourself. So A is a very good fellow, says, okay, I only will bring the 1 crore rupees. I only will bring the 1 crore rupees. Same type of business we will start. Same type of business will start. So only one person is putting all the money. Business will be same only. If 2 friends open a restaurant by putting 50 lakhs rupees, total money is 1 crore. So whatever the type of furniture they'll put, whatever the type of interior exterior they will have, same type of interior exterior they will have. Bond will be same only. Bond will be identical. There will be no difference in the bond. Just that type of bond is different. All the money is brought by A. So we will say this bond will be called as dative bond. Dative or other meaning coordinate bond. Coordinate bond. Coordinate bonds, I told you, are rare. Not every time you will see them. You will mostly see them in nitrate. You saw them in nitrate. You saw them in ozone. Nitrate, ozone. 2 examples you have seen till now. Nitrate, ozone. Nowhere else you saw the coordinate bond. You will see one more here in the NO2. And many more coordinate bonds will come in a particular chapter of class 12th called as coordination compounds. There also you are going to see coordinate bonds. Okay. So let's come back to this example. Oxygen said, I got 6 electrons with me. Kindly share 2 with me so that I become 8 and I become happy. Nitrogen says, okay, let's do that. So nitrogen shared 2 electrons. Oxygen also shared 2 electrons. Oxygen became happy. Now nitrogen says, already I am having 7 electrons. Already I am having 7 electrons with me. 1, 2, 3, 4, 5, 6, 7. Nitrogen says, I can't take one more pair. It's impossible for me to have one more pair. So I will to keep 7 only because I can't make it 8. How to make it 8? Not possible, no. 7 are there. Oxygen says, I want to share 2, but if nitrogen shares 2, nitrogen will get 9. 9 is not allowed for nitrogen. So nitrogen says, let's do one thing. Let's start a business where you don't bring anything. You don't bring anything, but I will share my electrons with you. I will share my electrons with you. And let's make a coordinate bond. let's make a coordinate bond. So this bond is a normal double bond, beta. This is a normal double bond, whereas this one is a coordinate bond. This one is a coordinate bond. So you can show it like this. Okay, show it specially like this, that nitrogen is saying oxygen, in your circle you can take my 2 electrons, but don't bring any of your electrons because I can't keep them. I don't have a space. So what does the structure become? Structure become N double bond O, 1 electron on the nitrogen. This is not a lone pair. Lone pair means 2 electrons on the head. 2 electrons on the head is called as lone pair. This is just a lone electron, single electron species. So let's keep a coordinate bond with one. Very important structure. Learn this. Learn this. Now let's make NO. Now you can easily think of NO as well. Nitrogen says I have 5. 1, 2, 3, 4, 5. Oxygen says I have 6. I want to share 2 with you. Nitrogen says okay, share with me. As soon as oxygen shares 2 with nitrogen, oxygen is happy with 8, but nitrogen can't get 8, so nitrogen gets 7, like this. Nitrogen gets 7. So structure become N double bond O. Oxygen has 2 lone pairs. Nitrogen has 1 lone pair and 1 single electron also. So it's an odd electron species. Remember the structure now. N double bond O, nitrogen carry a lone pair also, a single electron also. Okay. Here also oxygen have lone pair. You can show them as well. Generally showing the lone pair on the surrounding atom is not very important. Showing the lone pair of the central atom is more important. Okay. Same way, let's see chlorine now. Chlorine says I got 7 electrons. 1, 2, 3, 4, 5, 6, 7. Chlorine got 7 electrons. Okay. 1 oxygen comes from here, 1 oxygen comes from here, ClO2. Oxygen says, I want to share 2 with you. I have got 6, let me share 2 with you. Chlorine says, keep sharing. I can expand my octet. I don't have a problem in giving you a double bond. So this oxygen, you also share 2 with me, I don't have a problem. Chlorine says, you also share 2 with me, I don't have any problem at all. Because chlorine is, third period member. Chlorine has no problem in making how much ever bonds you want it to make. Chlorine says, how many electrons do I have now? I have now total 11 electrons around me. Can you see 11, everybody? 1, 2, 3, 4, 5, 6, 7. 7 though it already had. It made a double bond here. So 8, 9, 10, 11. So chlorine has 11 electrons in its octet now. So how the structure looks like? Cl double bond O, a single electron, which is this one, okay, and a lone pair like this. You have to learn these 3 structures. I have drawn them for you. This requires imagination. You don't have to imagine next time. I just told you that you have to learn these structures. So kindly learn them. Okay, kindly learn them. Then you will be able to do these things much better. You will not be able to draw these structures by any theory. You have to learn the structures of odd electron species. I have not made any coordinate bond here because chlorine tendency is there to not make a coordinate bond. Yesterday I told you, it will never make a coordinate bond. It will say to oxygen, take double. I don't have a problem. So ClO2 says, take double bond, take double bond. I have 11. I don't have a problem. Nitrogen says, take double, take a coordinate because I can't give you double. Now I have 7 electrons. This is NO. This is NO. So none of them are following the octet rule. None of them are following the octet rule. 7 in the valence, 7 in the valence, 11 in the valence. 7, 7, 11. So I hope coordinate bond is clear to everybody. Coordinate bond is bond formed by unequal, donation of electrons to make a covalent bond. Both are covalent bond only. Okay, this is a normal covalent bond. We call it as dative covalent bond. Both are covalent. Both are normal bonds. Both look like a line only. Both will have same bond length. Both will have same bond strength. Everything will be identical. Just that while showing a dative bond, we will show by a arrow. A, arrow, B. Like this. Dative bond. This also has 2 electrons. Normal covalent bond also has 2 electrons. Just that here both the electrons are given by A, There the electrons were coming half from A, half from B. This is our third drawback of Lewis. Okay, let's go for the fourth drawback. Fourth drawback of Lewis is that it cannot explain how noble gases make compounds. It cannot explain why compounds of noble gases exist. Okay, so noble gases also make their compounds in spite of having already a 8 electron. Octet is already there. So octet must not be the correct reason. They already have octet, they should not make compounds, but why do they form compounds? For example, remember, xenon only make compounds. XeF2 is one example, XeF4 is one example, XeF6 is one example, F2, F4, F6, and one more, XeOF4, XeO2F2, XeO3. These are the compounds of xenon which have been found in nature. I mean, xenon can make these compounds. These are all man-made. Okay, we have made these compounds for xenon. So nowadays we never say the group 18 as inert gases. They are not inert. We call them as noble gas. So there is a difference between noble gas and inert gas. Inert means I will not react. Noble means I will sometimes only react. So noble means less reactive. Inert means unreactive. So they are not inert in nature. They are noble in nature. Means they react very seldom. Okay, very few times they react. Like these are the compounds. All their structures we will study. And the final problem with Lewis is it could not explain anything about which compound is stable, which is less stable. It could not explain about any bond parameters like bond angle is what, bond strength is what, nothing it could tell. So fifth point, it could not explain about, stability of molecules. It could not explain about bond parameters like bond length. B means bond here, bond length, bond angle, okay, bond strength, which bond is strong, which bond is weak, whether a C double bond O is a stronger bond or C double bond N is a stronger bond or C double bond C is a stronger bond. It could not check. Okay, and then it could not talk about things like geometry of molecule, geometry and shape of molecule. But since it was a very good theory, given that what time it came, after all this theory only, we came to know about what are orbitals, what are subshell, which you study in your atomic structure chapter. So this is a good theory considering that we have no idea about what are shells. Or shells were known at that time, the Bohr model had already come, but we had no idea about what are orbitals, how orbitals will overlap to make bonds. So the next theories which will come, valence bond theory, VBT, hybridization, then the things will become more clear that why the bonding takes place. So octet is not the necessary step to complete, but there are other reasons for the bonding. So I hope it is clear to everyone till now. I'll just open the chat for next 5 minutes. You can just mention if it is crystal clear or not. Then we'll start the next topic. Chat. I'll open the chat for next 2-3 minutes. I will just see whether it is clear to you or not. Just tell me if it is clear or not. And then we are going to start with our next topic, that is drawing the structure more accurately using the concept of hybridization. Okay, that's good. That's good. All right. Okay, students. So this is all about our Lewis structures and drawbacks, the problems with Lewis. Good. All right. So now let us start with the next topic. Okay. So I will not be teaching you the topic in a very, detailed manner. Sir, please explain the definition of odd electron species. Shanmukh, anything with the odd number of electrons. What are odd numbers which are not divisible by 2 beta? So anything which contain odd electrons in their octet, in valence shell, 5 electrons, 7 electron, 9 electron, 11 electron, 13 electron, we call them as odd electron species. Okay. Examples, I have asked you to learn them. Okay. All right. Pranati, I just explained Pranati. Okay. So now we'll be talking about the next topic. You can stop the chat again. Okay. Now let's talk about drawing the structures more accurately using concept of VBT. VBT was the next theory which came after, Lewis dot structure. I will not be teaching you what is VBT. It is just few points that to make a bond, orbitals must overlap with each other. Overlap can be head-on overlap, parallel overlap, but all those things you will study anyways in the class. Right now, my aim is just to teach you the most important part, which is how to reach to a perfect structure. Okay, beta. Using concept of VBT, valence bond theory, and hybridization. Okay, hybridization is a concept which is actually known as mixing of atomic orbitals. Mixing of atomic orbitals. Okay, I'll just give you a hint of what is the meaning of hybridization, and then we are going to start with the concept. Okay, so let's say I am carbon and I want to make 4 bonds with hydrogen in CH4. Okay, in CH4 I want to make 4 bonds in methane. So carbon is having valence electrons, 4 are there, 4 valence electrons, and it wants to make 4 bonds with hydrogen. The thing is, when I write the electronic configuration of carbon, I hope all of you have studied that 1s2, 2s2 type of electronic configuration. So carbon, which is Z is equal to 6 electrons are there, carbon's electronic configuration is going to be 1s2, 2s2, 2p2. Okay. If you don't know how to write the configuration, then you'll have to wait for the atomic structure chapter to start. It is not at all required in this concept that I'm telling you. Just once I want to explain to you that why hybridization came into picture. Just I want to explain to you. Okay. So when I look at carbon's electronic configuration, it is 1s2. 1s is a single box, single orbital. 2s, s is always a single orbital. P is a 3 boxes together. 3 orbitals are there in the p subshell. So while filling the electrons, we use some rules, Afbauer principle, Hund's rule. This is how the electronic configuration of carbon looks like. 1s2, 2s2, 2p2. Now you should remember that the bonding always takes place from the valence electrons. Valence means the last shell which is there. So last shell is second shell here. I will just remove the first shell. Okay, although it is there, but it is not useful for you. This is not a useful shell for you. Only these people will start making the bonds. Okay. Now, whenever you want to make a bond, whenever you want to make a covalent bond, your orbital should hold only one electron if you want to make a bond. But now, though, I want to make 4 bonds, but I have only 2 electrons. So right now, the maximum capacity of a carbon is to make only 2 bonds. This can make 1 bond, this can make 1 bond. We call it as covalency. Covalency means ability to form covalent bonds. So covalency of carbon is 2 right now. 2 is not sufficient. Okay, in CH4 I need to make 4 bonds. 2 is not sufficient covalency. So whenever you want to increase the covalency beta, always do something called as excitation of electron. We do something called as excitation of electron. Again, I am telling this might be little out of your current, knowledge, that what is excitation, what is electronic configuration. But just to reach to a conclusion, why are we studying hybridization, I am telling you this. You don't require it at all. I'll give you a trick, just learn the trick. That is sufficient. So I want to do excitation. Excitation means by, taking some energy from the environment, the paired electron of the carbon can jump to the empty orbital like this. So this electron can jump here. We call it as first excited state. First excited state. So when carbon reaches to first excited state, I'll just write it as C star. Star means excitation has occurred. This electron will go there and its electronic configuration will start looking like this. 1, 2, 3, 4. Now the covalency is 4. Now the covalency is 4. Now we can start with bonding. Okay. Now the thing is, there is 1 electron in 2s orbital and 3 electrons in 2p orbitals. Okay. The thing is, s orbital has a much different shape than a p orbital. S orbital actually looks spherical in nature, like this, spherical, like a ball. And p orbitals are actually dumbbell shaped. 3 dumbbells are there. Px dumbbell, py dumbbell in the y-axis, pz dumbbell in the z-axis. Okay. Now if I think that carbon, you make bonds with hydrogen. You make 1 bond with hydrogen from here. 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 If I say hydrogen is coming with 1 electron, you make 1 bond here, 1 bond here, 1 bond here, 1 bond here, like this. If you do this, then the problem is carbon will say that, okay, I am using my 2s electron. So this is a 2s orbital and this is 1s of hydrogen. S orbital is spherical in shape. So carbon will be making 1 bonds with the s overlap. And other bonds will be made by a p orbital of carbon with the s orbital of hydrogen. P orbital of carbon with the s orbital of hydrogen. P orbital of carbon with the s orbital of hydrogen. So the bonds will be of different lengths. You don't have to draw it. Okay, you don't have to draw it. So this bond with hydrogen will be a different bond because hydrogen will always bring 1s. 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 So there will be 2 different types of bonds in CH4. A bond which is made by a 2s and 1s overlap, and other 3 bonds which are made by a 2p and 1s overlap. But when we saw the structure of CH4, we found that all the 4 bonds are identical in shape. All the 4 bonds are identical in shape. Then came the concept of hybridization into the picture. That how come in CH4 all the bonds are looking exactly the same length, exactly the same energy, exactly the same size, everything is same, but carbon though has different orbitals. Then we came to know, let's think of another concept of something called as mixing of orbitals, that pure orbitals carbon should not use during bonding. Pure S, pure P, pure P, pure P carbon should not use. Carbon should mix them first. It's almost like when 4 guests are coming to your house. Okay, 4 guests are coming to your house. Let's say 4 guests are coming to your house. This is first guest, this is second guest, third guest, fourth guest. And at your house, there are 2 things you have. You have rice and you have sambar. What do you have? You have rice. Let's say s orbital is rice and p orbitals are sambar. So when guests come to your house, you tell me, will you do this foolishness that to the first person you will give only rice and 3 people you will say, okay, you only eat sambar, sambar, sambar? Will you ever do that? Will you ever do that? Answer is no, sir. Are we mad? Why are we going to give rice to only one person and sambar to others? Then they will be differently attached to you. Rice person will feel very bad that I am not getting any taste. Sambar people will also feel very bad that our stomach is not getting filled. We are not having any carbohydrate to eat. So this is not a good way. This is not the correct way to feed your guest. How will you feed the guest then? You will take all the rice, you will take all the sambar and you will mix them together. You will make a khichdi. What do you say? What do you call it? Bisibili-bath, or you call it as sambar rice. Okay, so you will mix sambar and rice together and you will make a mixture of sambar rice. This mixing is called as hybridization. This mixing is called as hybridization. So you'll mix all the rice and sambar together. First you'll mix it properly. Then in each of the 4 plates you will serve sambar rice, sambar rice, sambar rice, sambar rice. So then everybody, all 4 guests will be attached to you in the identical way. Is it making sense to you? Yes. This is called as hybridization. So what is hybridization? Intermixing of atomic orbitals. What is it? Intermixing of atomic orbitals of central atom. I am not mixing the orbitals of the guest. I am mixing the orbital of the host, the one who is hosting. Who is the host? The central atom. So it is intermixing of atomic orbital of central atom having similar energy. So energy will not be same. 2s will have different energy, 2p will have different energy, but their energy will be little bit similar to each other, not much different. Like I can't mix a 2s with a 5p. Okay, 2s, 2p can mix, 3s, 3p can mix, 3s, 3p and 3d can also mix like that. So intermixing of atomic orbitals of the central atom to give rise to equal number of new hybrid orbitals. This is known as hybridization. So when you mix rice and sambar are pure orbitals. And when you mix them, you get bisibili-bath or whatever you call it. That is hybrid orbital. So whenever they will mix together, you will get equal number of new orbitals. We'll call them as hybrid orbitals. So before bonding, carbon will say, wait, do not make bonds yet. Hydrogen, don't come yet. Let me mix these orbitals. So we'll call it as sp3 hybridization. One s is mixing with 3 p's. sp3. You can have sp2 if you want to make 3 sigma bonds. You can have sp when you want to make 2 sigma bonds. So how many sigma bonds you want to make? Sigma bonds mean how many atoms you want to attach to you. Depending on that, you have to do mixing. If 2 guests come to your house, then you don't have to mix all S and all P's together. No. 1 rice, 1 sambar you will mix. SP hybridization. If 3 guests come to your house, you will take 1 rice, 2 sambars, you will mix them and make 3 plates of sambar rice. When 4 guests are coming, SP3 you will make. When 5 guests are coming, then you don't have 5 plates, then you have to use a d orbital. So carbon does not have a 2d orbital, but other people can do that. Sulfur can do sp3d hybridization, sp3d2 hybridization, sp3d3 hybridization when 7 guests are coming to your house. So depending on how many guests will come to your house, you will do some hybridization. It's not that simple as well, but I'll give you a trick to find the hybridization. Just tell me in a simple layman language, is the meaning of hybridization clear to you or not? Tomorrow we'll be continuing this. Sir, can you open the chat? I'll start the chat for some time. You can tell me in layman language, is it clear to you what is the meaning of hybridization? How to make sambar rice, how to make bisibili-bath. When someone comes to your house, never give them pure orbitals, never give them only rice and sambar, give them mixture. Tell me, is it clear to everybody or not? And then I'll continue in the next class, what is the meaning of hybridization. I'll wait for your reply. If it is clear to you, you can just like the video and leave the chat and I'll see you all in the tomorrow's class then. Yes. F orbital shape not required yet. Okay, do whatever I am telling you to do. Don't think extra. Don't think anything extra. Just do what I am telling you. Okay, good. Bye bye. Take care. I'll see you all in the next class. Bye bye.